So now we're going to talk about electronegativity. Um, we already talked a little bit in previous lectures in class about something called covalent bonds. And we said that covalent bonds form when atoms have similar electrical properties. Ionization energy was one way to quantify those electrical properties. So atoms that had similar ionization energies would form a covalent bond. Atoms that had very, very different ionization energies would not form a covalent bond. Another way to look at those electrical properties is something called electronegativity, and that's what we're going to talk about today in this lecture. Okay, so electronegativity is the ability of an atom to attract electrons. Some atoms are much, much better or much stronger and able to attract electrons to themselves. Other atoms don't have that same ability, and they're just not as good at attracting electrons to themselves. The higher the electronegativity, the more strength the atom has to pull electrons towards itself. And this becomes important in determining what kind of bond is going to form between two atoms. We need to look at the electronegativities of each of the atoms. Okay. Electronegativity, the electronegativity scale is something that was created by a scientist named Linus Pauling. This is a completely made up scale. He investigated all of the different elements and looked at how reactive they were. And he created an arbitrary scale. Arbitrary means that he pretty much made it up. So he made up this scale, and he assigned the element that had the highest electronegativity a value of 4. He could have assigned it a value of 300 if he wanted to, but he decided to use 4. And so fluorine is the most electronegative element. It's because fluorine is it's the element that is best able to attract electrons to itself. It has the most strength and is able to pull electrons towards itself. And so he gave that a value of 4. Every other element on the periodic table that has an electronegativity is going to have an electronegativity that's less than 4, because it's all going to be relative to fluorine. So all other electronegativities for all other elements are assigned relative to fluorine. So how did he know that fluorine was the most electronegative element? Oops, sorry, I got ahead of myself. It's because of the way that the fluorine atom looks, and it's because of the number of valence electrons that fluorine has. So if I draw a Bohr diagram of a fluorine atom, what I'm going to show is that in my nucleus, I have 9 protons, 9 protons, and I have a total of 10 neutrons. Okay. Sorry, I can't see any of this. Let me start this over because that was just really, really bad. I'm going to have to kind of draw over the top of what I've got here. So I'm going to draw my nucleus here. And this is my fluorine atom. Inside my nucleus, I have 9 protons, and I have a total of 10 neutrons. So that means a fluorine atom has 9 positive charges. A neutral fluorine atom is going to have 9 electrons. So let's start putting our electrons in the shells around the nucleus. And so our first shell can hold 2 electrons, so we've got 1, 2 electrons. And our second shell can hold up to 8 electrons. So we have a total of 9 to put in. We put 2 in the first shell, and so here's number 3, 4, 5, 6, 7, 8, 9. So a fluorine atom has almost a full valence shell. It's only missing 1 electron right here. If it had 1 more electron right there, it would be a very, very, very happy atom. And so the reason that the fluorine has the highest electronegativity is because there's not a lot of shells between the nucleus and its valence electrons. So the valence electrons are very close to their nucleus, and it only needs 1 more electron. So it really has a lot of strength to try to attract that last electron that it needs to create a full shell. So that's why fluorine is the most electronegative. All other atoms either have more shells between the nucleus and the valence electron, or they don't have as many valence electrons. And so all other elements are going to have electronegativities that are less than fluorine. Okay. It's actually the difference in electronegativity between two atoms that's going to tell us what type of bond is going to form between those two atoms. So we need to know, first of all, what are the two atoms that we're dealing with in a bond, and then we can predict what type of bond is going to form by looking at the electronegativities of each of those atoms by subtracting the electronegativities and figuring out whether those atoms are close together in electronegativity or whether they're really, really far apart. So if two atoms have similar electronegativities, it means that neither one is stronger than the other. They both have about the same strength. And so they're going to share the electrons that they use to bond together equally. This is a covalent bond. When the two when the two atoms share their electrons equally, that creates a covalent bond. Okay? If two atoms have different electronegativities, so slightly different, not a huge difference, but somewhat of a difference, then it means that one atom is slightly stronger than the other. What's going to happen in that case is that they're still going to share their electrons, but they're going to share them unequally. The atom that has the higher electronegativity is going to be able to pull those electrons towards itself a little bit harder, and those electrons are going to spend a little bit more time around the atom that has the higher electronegativity. The atom that has the lower electronegativity is still going to get to share the electrons, but they're just not going to spend as much time around the less electronegative atom. And so what happens is that creates a polar covalent bond. Covalent means that we're sharing electrons. Polar means that we're not sharing them equally. And so what's going to happen is the atom that has the electrons, that the electrons spend more time around, is going to have a slight negative charge around it. And the atom that has the lower electronegativity, it means that the electrons don't spend as much time around it, and it's going to have a slight positive charge. And that creates a polar molecule. So they're still sharing the electrons, but the electrons are spending more time around the more electronegative atom, which gives it a slight negative charge. They're spending less time around the less electronegative atom, which gives it a slight positive charge. That creates a dipole within our molecule. And remember, we said that water is a polar molecule. It has a dipole in it. It has a positive end and it has a negative end. And it's because the hydrogen and oxygen are not sharing their electrons equally. They're sharing them, but they're sharing them unequally. Okay? If two atoms have very different electronegativities, it means that one atom is much, much stronger than the other. And so the stronger atom is going to be able to just take the electron away from the less electronegative atom. This is an ionic bond because what's going to happen is we're creating two ions. The atom that takes the electron becomes a negative ion because now it has one more negative charge than positive charge. The atom that gives up the electron becomes a positive ion because now it has one less negative charge than positive charge. And the ions are attracted to each other because they have opposite charges. And so they're going to come together and they're going to form a crystal lattice, which is what our ionic compounds, when they're in a solid form, look like. Okay, so how do we predict what types of bonds are going to form? If the electronegativity difference between two atoms is small, and by small what I mean is if the electronegativity difference is less than 0.4, it means that those two atoms have about the same strength and they're going to share their electrons equally. And we're going to create a nonpolar covalent bond. And the term for this is they're going to create a molecule when they bond together, and it's going to be a covalent molecule, which means that it's not going to have any overall positive or negative areas or charges in it. Examples of this are elemental oxygen. So a molecule of oxygen is a covalent molecule, or a molecule of hydrogen is a covalent molecule. Carbon dioxide is also a covalent molecule, but that's more because of geometry than anything else. If the two atoms have an electronegativity, kind of a medium-sized electronegativity difference, and by medium-sized what I mean is if the electronegativity difference is greater than 0.4, but less than, your book says 2.1, but I'm going to change this and I'm going to say 1.7. So if the electronegativity difference between the two atoms is between 0.4 and 1.7, we're going to have a polar covalent molecule. So remember, covalent means that they share electrons, but polar means that they're going to share them unequally. Okay, it means that one of the atoms is going to be able to kind of keep those electrons for more of the time than the other one. We're going to create a polar molecule because there's going to be a dipole within that molecule. There's going to be an area that has a negative charge, and there's going to be an area that has a positive charge within the same molecule. So an example of this is water. That's one of the molecules we talked about. We talked a lot about it, and water has a dipole in it. Part of the water molecule is positive, part of the water molecule is negative, and that's what makes it able to dissolve both ionic compounds and polar compounds. Okay. If the electronegativity difference is large, and here your book says greater than 2.1, but I'm going to say if it's greater than 1.7, we're actually going to create an ionic bond. The two atoms are not going to share the electron at all. What's going to happen is the atom that has the higher electronegativity is just going to take the electron away from the other atom. So the electrons are transferred, they're not shared, and what happens is we end up with two ions. One is a positive ion, one is a negative ion, and they're going to stick together because opposite charges attract. So they'll be attracted to each other, and they'll stick together because of their opposite charges, and they'll form an ionic compound. And examples of those would be the salts that we talked about when we did the particular properties lab. See what else we have going on here. Okay. So if I look at the periodic table, I can kind of figure out different trends in electronegativity amongst the different elements on the periodic table. And so what happens is, as I go from the metals to the nonmetals on the periodic table, and remember, this side is the metals, and this side over here is the nonmetals. Okay. And so as I move from the metals to the nonmetals, as I go across a period, say I go across this period here, in general, what happens is my electronegativity is increasing as I move across the period. And that's because the highest electronegativity is going to be found here with fluorine. And all of the other elements around fluorine also have a very high electronegativity. As I move up a group, my electronegativity also is increasing. And so the lowest electronegativity is going to be found in this part of the table. And so as I move up a group, my electronegativity increases. And that's because the valence electrons are getting closer and closer to the nucleus as I move up that group. And as I move across a period, what's happening is I'm increasing the number of valence electrons until I almost have a full valence shell. And so the electronegativity increases because the atom naturally wants to fill up, atoms naturally want to fill up their valence shell. And so some things for you to remember are that electronegativity increases as I go across a period. The highest electronegativity is found in this part of the table. Electronegativity increases as I go up a group, and the lowest electronegativity is found down here in this corner of the table. Some of the noble gases don't have an electronegativity associated with them, and that's because they already have a full valence shell and they're very non-reactive. They don't want another electron. They don't want to bond with anything. Some of the larger noble gases, like down here, krypton and xenon, they're so big that their valence electrons are really far away from the nucleus. And so if they react with something that has a very high electronegativity, it's possible to form a compound out of them. But there's not very many known compounds that form with any of the noble gases. That's probably a little bit more information than you actually need. So that's just kind of FYI, you really don't need to know it for a test. Okay. And we're done with this.